All right, so this video is going to cover Module 5, Homework 4, Factoring by Special Products. So we talked about factoring in this Module 5 so far, but these are just kind of special cases. So factor completely, simplify if possible, 2t squared plus 40t plus 200. With every one of these problems, we can do it exactly the same like we've been doing, so it's really nothing new to learn. So our first step in factoring every single time, no matter what, is GCF. So I notice they all have a 2 in common. So let's factor out that GCF of 2. So in doing so, this 2 is coming out front as our GCF. So 2t squared divided by 2 will leave us with t squared. Positive 40t divided by 2 will leave us with positive 20t. And then 200 divided by 2 will leave us with positive 100. So just like we did in the past, 2 is already a factor, 2 is already an answer, so I'm just going to leave it out front. I'm going to cover it up just so that way I don't get confused, because now I'm just worried about factoring whatever's left over. I'm just worried about factoring t squared plus 20t plus 100. So this is in standard form. Just remembering real quick, our standard form is our ax squared plus bx plus c. It's our standard form. So that means a in front of t squared is positive 1. We do. So a is positive 1, b is positive 20, c out by itself is positive 100. So yay, or before I even say yay, let's do our template. So two numbers that multiply together to give us a times c, and the same two numbers that add together to give us b. A times c is 1 times 100, so 100. B is 20. So two numbers that multiply together to give us 100 and add together to give us 20. I'm thinking 10 and 10. So 10 times 10 is positive 100. 10 plus 10 is positive 20. So that's good to go. What I was saying yay about was that A is 1 this time. A is 1. So we can use a shortcut if you want. I know most people want to use a shortcut, but if you don't want a shortcut, just factor by grouping as if you were any other problem whenever A is not 1. You'll get the same answer in the end. But because we can use a shortcut, let's go ahead and use it. Remember, the shortcut says we can have our 2 factors. Our shortcut says we have our 2 factors. Our variable, this is really important, our variable is t, so make sure that you use the letter t. So our variable is t, and our blanks are positive 10 and positive 10. So t plus 10 times t plus 10. So if you notice, what makes this one special is t plus 10 times t plus 10 is the same thing twice. So I can rewrite this as t plus 10 squared. Notice it says simplify if possible. This is our simplest form. So if you didn't write it as squared, it would be like where it says in the homework something like your answer is correct, but it's not in the right form or something like that. So it won't mark it correct unless it's simplified like this, t plus 10 squared. Lastly, don't forget, you're covering up your GCF, so don't forget to bring that GCF down. So bringing that 2 out front, we're left with our final answer of 2 times t plus 10 squared. Multiply your factors back together, you get back to your original problem. So that's just what makes it special. Everything else is exactly the same. You could just write it as squared, a perfect square. Let's do this next one. Factor the following expression completely. 64x cubed minus 48x squared plus 9x. So GCF, they all have an x in common, but that's it. They don't have any numbers in common. 48, 9 does not go into 48 evenly. 3 would be another option. But let's see, is 64 divided by 3? No, so 3 doesn't go into every single term. So no numbers that they all have in common. But they do have a GCF. They all have an x in common. So let's factor or divide out that GCF of x. So that GCF of x is coming out front. We are left over with 64x squared minus 48x plus 9. So that GCF is already a factor. It's already part of our answer out front. So again, I'm just going to cover it up just so I don't get confused and put it inside this. Because all we're doing now is factoring whatever's left over. We're factoring 64x squared minus 48x plus 9. So our A value in front of x squared is positive 64. Our B value in front of x is negative 48. C out by itself is positive 9. So we're looking for two numbers that multiply together to give us A times C, and the same two numbers to add together to give us B, which is 48, negative 48. So B. All right, so two numbers that multiply together to give us A times C. So 64 times 9, which would give us 576. And the same two numbers to add together to give me B, which is negative 48. So I went down the list. So 7, I just kept trying numbers. To save you time. I got down to 24. 24 and 24 multiply together to give me 576, and I know can add together to give me 48. So 24 and 24. In order to multiply together to be positive 576, they had to have the same sign, but in order to add together to be negative 48, they both should be negative. So negative 24 times negative 24 is positive 576. Negative 24 plus negative 24 is negative 48. All right, good. Hard part's done. Unfortunately, our A value is not 1, so we must factor by grouping here. We can do it, just extra step or two. Nothing crazy. So let's go for it. So 64x squared is going to stay the same. Instead of that middle term, instead of that negative 48, we're going to split it up using the numbers in our blanks. So instead of negative 48, we're going to have negative 24x minus 24x, and then that plus 9 is going to stay the same. So now we have 4 terms. We can factor by grouping. So group the first two, group the last two. Notice this negative sign stays with the 24x. So looking at our first two, 64x squared minus 24x. 8 goes into both of them, and they both have an x in common. So 8x. So factoring or dividing out that GCF of 8x, we're left over with 8x minus 24x divided by 8x would give us 3. So 8x minus 3. Now looking at our next two terms, negative 24x plus 9. In the back of my mind, I know I want positive 8 minus 3 to be left over. Positive 8 minus 3. So GCF here, I know they both have a 3 in common. But I'm going to factor out negative 3 to make sure that I'm left over with a positive 8 and a negative 3 whenever I factor out that GCF. So factoring out negative 3, we're left over with negative 24x divided by negative 3, so positive 8x. 9 divided by negative 3 would give us negative 3. So 8x times 8 minus 3 times 8 minus 3. So we know we did it right because they both have 8 minus 3 in common. So that will be one factor, 8x minus 3. Taking out the 8x minus 3, we're left over with another 8x minus 3. So notice it's 8x minus 3 times 8x minus 3. So same thing twice. So we can write it as 8x minus 3 squared. But we're not done because remember we had that GCF we were covering out front. So don't forget to bring down that GCF of x. So now here is all of our factors. Here is our final answer. X times 8x minus 3 squared. All right, let's do another one. So factor completely. 9x, I don't know what I'm talking about. Factor completely. R squared minus 64. So R squared minus 64. So our first step in factoring, no matter what, is GCF. But there's nothing that R squared and negative 64 have in common, so no GCF. Here's what's kind of funky. So we need to put this in standard form, and it is in standard form. But remember, our standard form is ax squared plus bx plus c. So I could rewrite this as r squared. There's no term with just r. There's no middle x term here. So it would be the same thing as saying plus 0r, because there's no r's. Kind of like a placeholder that we did for dividing by synthetic division, module 2, homework 9. And then c is negative 64. So now I have this in our real standard form, r squared plus 0r minus 64. So we can see a in front of r squared is positive 1. B in front of R is 0, and C out by itself is negative 64. So we're looking for two numbers that multiply together to give us A times C, and the same two numbers to add together to give me B. So A times C, so 1 times negative 64, which is negative 64, and add together to me B, which is 0. So 8 and 8 would multiply together to give me 64, and I could subtract them to get 0. Let's look at our sign. So in order to multiply together to be negative 64, one has to be positive, one has to be negative. And in order to add together to give me 0, they're the same, so one has to be negative. So 8 times negative 8 is negative 64. 8 plus negative 8, or 8 minus 8, gives us 0. So notice 8 and negative 8 are the only two numbers that will satisfy both conditions. All right, so we filled in our blanks. Thankfully here, our A value is 1. So we can use our shortcut if you want to. So our shortcut says we have two factors. Our variables are, very important, make sure you write R. And your blanks are positive 8, so R plus 8 is one factor. And our other blank is negative 8, so R minus 8 is our other factor. No GCF to bring down. So we're done. R plus 8 and R minus 8. Notice these are conjugates. Remember going back when we did conjugates? So these are conjugates. Remember, conjugates means they're the same term but different middle sign. So R plus 8, R minus 8. Same terms, different middle sign. So same terms, different middle signs. They're conjugates. So also notice, grab a different color, that here we are subtracting two. Oops. We are subtracting two perfect squares. We are subtracting, because it's r squared minus 64, so we are subtracting two perfect squares. R squared is r times r, and 64 is 8 times 8. So really we could use this to go straight from our problem to our answer. So GCF first, there's no GCF, and then we said r squared was r times r. We're subtracting, so we know we're going to have different signs. We're going to have conjugates. One's positive, one's negative. 64 is 8 and 8. So that's a great way to use another shortcut if you want to. If you don't want to use a shortcut, that's fine. Do it the way we've been doing it. You're going to get the same answer. So these are difference, because they're subtracting. Difference means subtracting of perfect squares. R squared is a perfect square. R times R. 64 is a perfect square. 8 times 8. So this only works whenever you're subtracting two perfect squares, whenever it's a difference of perfect squares. All right, let's go to the next page and let's try another example. So factor completely. 2x squared minus 50, our first step in factoring no matter what is GCF. I notice they both have a 2 in common, so let's factor out that GCF of 2. So factoring or dividing out, my dog is snoring, so I'm sorry if you hear that in the background. Divided by 2. So this 2 of GCF comes out front. We're left over with 2x squared divided by 2, which is just x squared. Negative 50 divided by 2 is negative 25. All right, perfect. So that GCF of 2 is done. And we're left over with x squared minus 25. If you notice, this is another difference of perfect squares. We are subtracting, so it's a difference, 2 perfect squares. Write that down first. Difference of perfect squares. So we can use that little shortcut that we just talked about and go straight to our answer. So we have our 2 factors. X squared is a perfect square because we know it's x times x. It is the difference. It is subtracting, so we know one's positive, one's negative. 25 is a perfect square, 5 times 5. Done. So x plus 5, x minus 5. Don't forget to bring down this GCF of positive 2, and that's your answer. So 2 times x plus 5 times x minus 5. Multiply all these factors back together, you get back to your original problem. Super cool. All right, let's do another one. This one kind of looked funky because it was kind of written backwards, but it's the same thing. So factor completely, 64 minus t squared. Our first step in factoring, no matter what, is GCF, but there's nothing that 64 and negative t squared have in common, so no GCF. I noticed that we are subtracting 2 perfect squares. So again, this is a difference of perfect squares. I'm glad that she's snoozing good. I don't know if y'all could hear or not, but my dog's over there snoring like crazy. It's a difference of perfect squares. All right, so we are subtracting 2 perfect squares. So let's look at our 2 factors here. So 64 is a perfect square because it's 8 times 8. We are subtracting, so that means we have different signs. So one's positive, one's negative. T squared is a perfect square, t times t. Done. This is our answer. 8 plus t times 8 minus t. If you don't like that, go back and do it the way we've been doing it. Factor by grouping if you want, same thing. But we can go straight to there, and that is our answer. So I did have a couple people ask me, well, what if I don't like it this way and I want to move it around? And they wanted to move it, because people asked me, let's go ahead and do it. They wanted to move it into negative t squared and then positive 64. They wanted to put that t squared out front, which is fine. Just remember that t squared is negative and the 64 is positive. So make sure whenever you pull it out front, you do it like this. So in this case, what really helps here is our GCF could be negative 1. So if we factor or divide out negative 1 as our GCF, we're left over with t squared minus 64. So now it's a difference of perfect squares. We're subtracting 2 perfect squares. We can go straight to our 2 factors. T squared is t times t. One's positive, one's negative. 64 is 8 times 8. Don't forget to bring down this negative 1. And that could also be your answer. Looks a little bit different. So negative 1 times t plus 8 times t minus 8. The glare's getting my pencil, sorry. There. That's better. So negative 1 times t plus 8 times t minus 8. If you multiply these all together, you get back to your original problem too. So it's okay. Even though they look a little bit different, the homework would take both of them. This one, to me, it's just a little bit easier. Just one step and then go for it. But whatever way you like better, either one will work. Either one is correct. All right. I'm going to put this right here, and let's keep going. So factor each of the following expressions completely over the integers. Okay, so 245z plus 20. So it says to factor. Our first step in factoring, no matter what, is GCF. So I see that 5 can go into both 245 and 20. So let's factor out that GCF of 5. So 5's coming out front. We are left over with 245 divided by 5, which would give us 49z plus 20 divided by 5, which is 4. So 5 times 49z plus 4. This isn't squared, so I can't do anything to factor further. Done. So let's look at the next one. Looks super similar, but now we have z squared. So 245 z squared plus 20. So again, we have a GCF of 5. They both have 5 in common. They both are divisible by 5. So let's factor or divide out that 5 as our GCF. We know 245 divided by 5 is 49, so 49 z squared. 20 divided by 5 is positive 4. So it's z squared, so we usually try to factor it. So with this one, we have 49z squared plus 4. The 5 is already done, so if you want to cover up the 5, go for it. These are two perfect squares. 49z squared is 7z times 7z, and 4 is 2 times 2. But it's not a difference of perfect squares. We are adding. So let me do it over here on a side note. If we were to put this in standard form, I'm going to forget about the 5 for just a second. So 49z squared plus 4. Let's put this in standard form. So 49z squared, there's no z term, so plus 0z plus 4. So that way it's in ax squared plus bx plus c form. So a in front of z squared is positive 49. B in front of z is 0. C out by itself is positive 4. So we're looking for two numbers that multiply together to give us a times c, and the same two numbers to add together to give me b. So a times c, 49 times 4, which would give us 196. And then add together to be b is 0. So if you look on here, nothing's going to work to fill in our blanks to give us 0. Because they have to have the same sign. Someone said, okay, well, 14 times 14 is 196. Okay, but they have to be the same sign in order to be multiplied together and be positive. If they're the same sign, positive 14 plus positive 14 is not 0. Even if they're negative, negative 14 plus negative 14 is not 0. So because this is a positive, it's not the difference of perfect squares, nothing works to fill in my blanks. So nothing works in blanks. So that means it cannot be factored further. And I say further because we did take out that GCF, so we did factor something, we just can't factor it anymore. So you can see that part. All right, so because of that plus sign, we can't factor it further. We are done. I'm going to write a little note though on the side. So it's adding, so it's not a difference. Remember, difference means subtracting. Of perfect squares. Because it's adding, it's not a difference of perfect squared because it's adding. I'll write on here because adding. So cannot factor further. So we just have to leave it. Can't do anything else. All right, let's do this next one. 245z squared, now we have minus 20. So again, same GCF of positive 5. So factoring and dividing out that 5. We're left over with 245 divided by 5, which is at 49 z squared. Now negative 20 divided by positive 5 is negative 4. So now because we are subtracting, now this is a difference of perfect squares. So we can go straight to our two factors. So now this is a difference of perfect squares. We are subtracting two perfect squares. Now that 5 are GCF, so that's already done. That's already out front. 49z squared is a perfect square. It's 7z times 7z. Different, so one's positive, one's negative, and 4 is 2 times 2. Don't forget to bring down that GCF of 5, and that's our final answer. 5 times 7z plus 2 times 7z minus 2. So this negative makes it where these signs are negative, and then that middle term would cancel out. All right. Let's go to our next page. We have a few more. We'll talk about. Just throw this right here. Okay, so factor the expression. 25x to the 16th power minus 16y to the 6th. So these look crazy, but it's really not the same thing. So our first step in factoring, no matter what, is GCF, but there's nothing that both terms have in common. So no GCF. Notice we are subtracting two perfect squares. So this would be a difference of perfect squares. We can go straight to our answer. Difference of perfect squares. So we have two factors. 25x to the 16th power. We know 25 is 5 times 5. And remember, whenever you multiply these two together, you're going to add the exponents. So what plus what would give us 16? And I want it to be the same thing on both. So x to the 8th times x to the 8th. Because 5x to the 8th times 5x to the 8th, whenever you multiply this, 5 times 5 is 25. X to the 8th times x to the 8th, you're going to add your exponents and give you x to the 16th power. You're going to add the exponents when you multiply. So we are subtracting, so it's a difference. So one's positive, one's negative. 16y cubed would give us 4y. I think I already said the answer. 16y to the 6 would give us 4y cubed times 4y cubed. 4y cubed times 4y cubed. 4 times 4 would give us 16. Y cubed times y cubed. Whenever you multiply, you add the exponent. So 3 plus 3 would give us that 6. There was no GCF to bring down. We're done. That's our final answer. 5x to the 8th plus 4y cubed times 5x to the 8th minus 4y cubed. So something different. Right when you're getting used to it, they throw in something different. So the last thing that we're going to talk about for this section is sum or difference of cubes. So it says factor completely using the formula for sum or difference of cubes. Remember that cubes means the third power. So like x cubed. So here we have w cubed plus 64. So it's adding. So because it's adding, we know it's going to be a sum. So our first step in factoring every single time is GCF, but looking at this, there's no number that, or nothing that w cubed and 64 have in common, so no GCF. But this is a sum of cubes because w cubed is w cubed plus 64, which 64 is 4 times 4 times 4. So 64 is 4 cubed. So for our cubes, we have a formula, and it's just a matter of you have to know this formula. It's not going to be given to you on the test. You have to know it for the test, and then just plug it into the formula. So our formula for sum of cubes is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So that is our formula. So now that we have it like this, we could see that a cubed, so a would be w, and then b would be 4, because b cubed would give 4 cubed, so b would be 4. So wherever I see an a, I'm going to put w. Wherever I see a b, I'm going to put 4. So a, which is w, plus b, which is 4, times a, which is w, squared, minus a, which is w, times b, which is 4, plus b, which is 4, squared. And that's it. I just going to have to simplify it a little bit. So we have w plus 4 times w squared minus w times 4, which I can write as 4w, plus 4 squared. 4 times 4 is 16. And boom, that's your answer. This last part, even though it's squared, it can never be factored, so don't even waste your time trying to factor it. That's your answer. You're done. So w plus 4 times w squared minus 4w plus 16. Let's do this next one. So factor completely using the formula for sum or difference of cubes. Now we have r cubed minus 125. So because now we have minus, we have a difference of cubes because of that subtraction. So we know r cubed is r cubed minus 125. We know 125 is 5 times 5 times 5. It's 5 cubed. And if you didn't know that, just try to plug in numbers into your calculator to figure it out. Also, if you want to do the cubed root in your calculator, just to kind of show you while we're here, we talked about this in test 2, but just to show you again, you need to use this x root power. So you need to plug in a 3 to show your calculator that you want the cubed root. And then do second, hit the second button right here, and then go down to the x root, which is right here, this caret button. And that will tell you the cubed root. It's putting that little 3 in for x. So the cubed root of 125 tells us 5. So it's telling us 5 times 5 times 5 will give us 125. 5 to the third power. All right, so now we have to have our difference of cubes formula. So it's the same concept, r cubed minus r cubed, and we get a cubed minus b cubed. We get a minus b times a squared plus ab plus b squared. So notice, I wanted to put these on the same thing because notice they're the same exact formulas, just different signs. So this one's for positive, this one's negative. So notice the same sign, it's the opposite sign. and this last one's always positive. So same sign that's given in the problem, the opposite side of what's given in the problem, always positive. So again, same sign that's given in the problem, opposite sign that's given in the problem, always positive. So really it's only one formula that you really have to remember, and it's just a matter of how to change it to make the two separate formulas. All right, so for this, we have r cubed minus 5 cubed. So wherever we see an a, we're going to put r. Wherever we see a b, we're going to put 5. So we have a, which is r, minus b, which is 5, times a, which is r squared, plus a, which is r, times b, which is 5, plus b, which is 5 squared. So just like we did on the previous problem, let's just kind of simplify it a little bit to make it look a little bit nicer. R minus 5 times r squared plus r times 5, which you can rewrite as 5r, plus 5 squared, which is 25. Again, this last, even though it's r squared, this can never be factored, so that's your final answer. R minus 5 times r squared plus 5r plus 25. All right, so I think this is going to be, yep, last page for this section. So factor completely, 125x to the 6th minus 64y to the 6th. Our first step in factoring every single time is GCF, which I didn't put no GCF here, but I understood, like, r cubed minus 125, there was no GCF. My bad, I just wanted to go back and correct myself there. Our first step in factoring, no matter what, is GCF, but there's nothing that 125x to the 6th and negative 64y to the 6th have in common. So no GCF. But notice, this is a difference of cubes. So we could use our difference of cubes formula. Let me write that over here. So difference of perfect cubes this time. I know it's not squared because I know the square root of 64 is 8, but the square root of 125, it doesn't go evenly, so it's 125 is not a perfect square. But we know from the previous problem, 125 is a perfect cubed. It's 5. So we know 5 cubed would give us 125. And then x squared cubed would give us x to the 6th. Remember, whenever you have x squared cubed, you're going to multiply these exponents. 2 times 3 is what would give you that 6. So here you could multiply the exponents. So minus 64, which I know 64 is 4 times 4 times 4, so 4 cubed. And then again, y squared cubed would give us y to the 6 whenever you multiply exponents. So I have a perfect cube minus a perfect cube. So we can use our difference because we're subtracting perfect cube formula, which we said from the previous page was a cubed minus b cubed, which equals a minus b times a squared plus ab plus b squared. So wherever we see an a, we're going to put in 5x squared. Wherever we see a b, we're going to put in 4y squared. So we have a, which is 5x squared, minus b, which is 4y squared, times a, which is, make sure you put parentheses here, 5x squared squared, because you're squaring the 5 and you're squaring the x squared, plus a, which is 5x squared, times b, which is 4y squared, plus b, which is 4y. Let me move that. I don't like that. Sorry. I just spit it all over so you can see it better. All right. So we have a, which is 5x squared, minus b, which is 4y squared, times a, which is 5x squared, plus a, which is 5x squared, times b, which is 4y squared, plus b, which is 4y squared, squared. Still smushed, but it's okay. So then just writing it better. So 5x squared minus 4y squared times 5x squared squared. So it's 5x squared times 5x squared. So that squared is going to go to the 5 and it's going to go to the x squared. So 5 squared would give us 25. X squared squared, remember multiply your exponents, would be x to the 4th power plus 5x squared times 4y squared. So 5 times 4 would give us 20. X squared times y squared plus 4y squared squared. Remember that squared is going to go to the 4, so 4 squared is 16. Y squared squared would give us y to the 4th. And that's our final answer. 5x squared minus 4y squared times 25x to the 4th plus 20x squared y squared plus 16y to the 4th. So kind of a tricky one. That's why I wanted to include it on our notes. So last one, factor completely using the formula for sum or difference of cubes, 27 m to the 4th plus 8m. So GCF here, they both have an m in common. So actually I have a GCF this time. So our GCF is going to be m. So I can factor or divide out an m from both terms. In doing so, we're left with 27m cubed plus 8. So now I know that these are perfect cubes because 27 is 3 times 3 times 3. And then m cubed is m cubed. So 3m cubed. So 3m times 3m times 3m would give us 27m cubed. Likewise, 8 we know, so plus 8 is 2 times 2 times 2. So 2 cubed would give us 8. That m, remember, is our GCF. It's just hanging out front. It is already an answer for us. So if you need to cover it up, go for it. We are adding. So because we are adding, we're going to use the sum formula. Remember, our sum formula says a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So wherever I see an a, I'm going to put in 3m. Wherever I see a b, I'm going to put in 2. So we have a, which is 3m, plus b, which is 2, times a, which is 3m squared, 3m times 3m. So make sure to put it in parentheses. That way that squared goes to both the 3 and the m. Minus a, which is 3m, times b, which is 2, plus b, which is 2 squared. So now just kind of making it look nicer. So we have 3m plus 2 times 3m squared, 3m times 3m, which is 9m squared, minus 3m times 2, which is 6m, plus 2 squared, which is 4. But don't forget to bring down, we had that GCF of m. Don't forget to bring down that m out front. And this is our final answer. M times 3m plus 2 times 9m squared minus 6m plus 4. So, lastly, notice down here I put the formulas for you. So the sum of difference of cubes, a cubed plus b cubed is a plus b times a squared minus ab plus b squared. Difference of cubes is a cubed minus b cubed. So we're going to do a minus b times a squared plus ab plus b squared. I kind of made note of this, but just to kind of show you, this sign is always the same sign. This sign is always the opposite sign. And then this sign is always positive. So same for both. So same sign, opposite sign, always positive. I guess I'll write it down here while I'm writing it. So same sign as this. This is going to be the opposite sign. And then this last sign is always positive, just to kind of help you. So same, opposite, always positive. Same, opposite, always positive. All right, and that is all of Module 5, Homework 4. If you have any questions, please let us know. If not, thank you very much for watching, and you can now complete Module 5, Homework 4 homework assignment. Thank you.